Gaurav sir, please start the session, sir.
Thank you so much. A very good afternoon to all the attendees who have come here for the Aosr AI webinar. After months of planning and enthusiasm and a good support from our respected President, Dr. Evelyn Ma'am, Dr. Shohang Ten sir, and Dr. Hemant Patel sir, finally we are live today with our webinar on artificial intelligence. This is the first part of many webinars we are going to do in artificial intelligence as a part of the Emerging Trends Committee. Today's webinar is directed for all those enthusiasts in research for AI who want to do something but don't know where to start, how to understand the paper, what are the potential topics, and what are the steps involved. And we want to ignite the minds of radiologists who wish to become the front runners of AI research in radiology and in healthcare. I would like to welcome the legend, Professor Ng Guang Hong, who is a medical physicist and is winner of the award of prestigious Marie Skłodowska-Curie, and also our president, Madam Dr. Evelyn Ho, our chairman of the Emerging Trends Committee, Dr. Shohang Ten sir, and the chairman of the Education Committee of Aosr, Dr. Hemant Patel sir. I welcome you all. I would also like to welcome the speakers of today, Dr. Vidur Mahajan from India, Dr. Daniel Ting sir from Singapore, and Dr. Chang Min Park sir from South Korea. So without much ado, we would like to start our session. The first speaker for today is Dr. Vidur Mahajan, who is going to talk on what are the potential topics of AI research in radiology. Dr. Vidur is the Chief Executive Officer at Carpal.ai, the world's first end-to-end platform for testing and deployment of medical imaging AI solutions. He also runs Mahajan Imaging, the leading imaging center of excellence in Delhi, India. Over to you, Dr. Vidur.
Thank you so much, Dr. Gaurav, for giving me this opportunity. It's indeed an honor. And when I obviously you'll notice that I'm not a radiologist. I am a plain vanilla GP, and then I went ahead, did an MBA, and now I do AI research and run a company that enables a lot of AI research. So it's okay, something has changed. Anyhow, so it's an honor for me to be able to present some of my thoughts, some of my opinions on what are the cutting edge but useful research areas that that radiologists across the world can dive deep into and bring about tangible impact. So if it's okay, Sarita, can I share my screen now?
Okay. Sure, sir.
So jumping right in, what is the radiology AI value chain, right? So I was just thinking about this, how should I start by opening up the opportunities that exist in research today? Well, very broadly, there are three levels that you can think of. First is the AI development level, where you are building an AI application. Then comes in AI validation, when you're trying to figure out, does the solution actually work? And the last is production, which is when you're using an AI application in your day-to-day life and deriving benefits from it, or not deriving benefits from it, which is another area of research. If we go deep into the first section, which is AI development, everything starts with problem definition. If you think of it today, the user of AI applications are radiologists. The beneficiaries of these applications are patients and referring clinicians. So what problem an AI algorithm should go out and solve is actually extremely important. And if you look at the point right under this, data sourcing, you realize that over the past 5 years, 2016, 2017, when AI started coming into our world, a lot of the papers, a lot of the research, a lot of the products were actually inverted. What that meant was that people were building because data was available and not because there was a problem to be solved. So now, the way we are thinking about things is you define a problem first, and there's huge amounts of research that can be done just around problem definition using AI, and then you go ahead source data, right? That's the second thing. I believe that building a mammography breast cancer classification algorithm is a good problem to solve. So then I go ahead and start sourcing data. Again, huge amounts of research that can be simply done in this very, very narrow domain of data sourcing. After that, someone or something has to label and annotate this data. The Achilles heel of deep learning is the data that it is trained on, and the problems associated with that data start showing up in this production phase. So very, very important phase. And after that comes model development, when this is when the data scientists get in, start training algorithms, figuring out which is the best way to train an algorithm, so on and so forth. So this is how, at a very high level, the AI development value chain works. After that, once you've got the AI built, you go to validation, right? And validation is to answer a very simple question: does it work? Is it useful? Right? So the first thing that we try to establish is clinical performance. Does the AI even deliver the kind of performance that we expect from it? Right? Huge world of research over here. Every radiologist on the planet can contribute to this, and we'll get into how that can happen. Next is clinical value. Is it even clinically useful? Right? There's a lot of AI out there that's really great, has great performance, but clinically is not very useful, right? We'll dive into a couple of examples of that as well. But again, clinical value determination is another area, and along with that, we all know what money makes the world go round. We cannot forget economic value. If there is an AI system that somebody has built out that increases cost, does not reduce, does not improve outcomes, it may be the most amazing system on the planet. Nobody is going to be using it. So this is the second phase of validation. The third phase is of production, right? Production is essentially putting these solutions into clinical workflows. The first step there is this concept of pre-deployment testing that we try to propagate, which essentially means taking an AI system, running it on retrospective data that is very similar to what you would get in a prospective environment, to try to build hypotheses around what kind of performance to expect from an algorithm at a particular hospital in the future, right? Huge area of research. Then workflow integration. This is one of the most difficult pieces of AI integration. What button does a radiologist press to see an AI output, or do they not press any button, or is it integrated into their packs, into their wrists, into their 3D workstations, or do you have an app on a phone? How do you actually interact with these AI applications? What is the machine learning ops, ML ops side of things? Again, very technical. How do you ensure security? How do you ensure that the AI runs in the fastest possible way? So on and so forth. And lastly, is an area that has recently come up, which is AI monitoring and testing, right? Monitoring, there are concepts of data set drift and model drift that are emerging, where you can essentially try to figure out should AI run on a particular scan or not? Those kind of questions. So, a lot of time spent on this one slide. We'll come back to it, but I think this encapsulates the problem sphere at a very high level. From a research point of view, you can actually have two research objectives, and the more honest you are about your objective, the easier it will be, in my opinion, to go for. The first is to publish papers, right? My sole goal is to publish papers. I want to have the best, impact factor on the planet, or so on and so forth. And we see this is just a very quick analysis I just did of number of papers with the subject keyword deep learning indexed on PubMed over the past 3 years, and we see that there is an exponential rise, right? And here, you have to obviously focus on novelty is the key. If you just want to publish papers, utility may be secondary, because it should be something that no one's done before. Novel metrics, or you can build out thought leadership. There's a lot of journals out there today that are looking for newer and newer kind of things to publish. And of course, open sourcing data is actually the easiest way to get the highest citation score that you can imagine. So you take like 300,000 MRIs, open them up for the world. Every paper that gets published using those MRIs is going to cite you, right? So very fast way of getting success in this domain. The other side is building products, right? This is just a snapshot from RSNA a couple of years ago, all the companies that were there on AI. But building products involves economic analysis. Why are certain tools not being used? Or what would make a tool useful? Focus is on utility versus novelty. Boring applications might actually be really, really good because they might be the most useful. And the focus is on building intellectual property, not as much on open sourcing whatever intellectual property you build, because at the end of the day, products are built by companies. Companies want to deliver shareholder value, and in order to build shareholder value, they require revenue. So this is another framework to think about things. Uh, some open research areas that we focus on as a team at Carpal are these. I'll go deep into each one of these. Implications of AI is one of the most understudied um, sections of the world of AI. What does this mean, right? We all look at summary statistics of AI performance, but nobody actually goes deep into seeing that even in an algorithm, for simplicity's sake, that is 99.9% accurate. So it makes one mistake out of 1,000. What are the consequences of that one mistake, right? Is it a clinical blunder that the AI is committing, and thereby nobody is going to be using it, right? What are commercial consequences, right? Something that nobody is really answering. An example of this is, this paper that came out several years ago that said that, AI tools can now predict Alzheimer's more than 6 years before the actual diagnosis, right? And this got a lot of publication. It was all over our WhatsApp groups and everywhere that now, we can diagnose Alzheimer's much earlier. And this was the paper behind it. It was in Radiology. Beautiful work, no doubt. But the moment you dive deep into things, you would realize that the truly independent test set was just 40 patients and it had 6 false positives, right? So, what are the implications of telling 6 patients that you are going to get Alzheimer's and then they don't get it? Maybe they get it because you told them, right? So again, nobody's thinking about these things. Another example was this work from MIT that said that you can diagnose breast cancer 5 years in advance on mammograms without actually seeing the scan on a mammo. Very, very dangerous territory, and no open area of research as to how do you deal with these solutions, right? This was the actual paper, and if you think of it, the AUC was 0.70, right, which is actually not very good, right? So how do you deal with consequences? How do you deal with implications of AI? Second, moving ahead, are technical issues associated with AI that are huge areas of research, and this, in my opinion, should be dominated by radiologists, and I'll tell you why, right? So the first issue is of generalizability. Generalizability is this problem of deep learning where you take an AI algorithm, you train it on data from one hospital, and then you take it to another hospital and you try to run it there, and its performance is severely worse, right? And this is an open problem. It's because deep learning, draws these uh, correlations within data that can be very specific to a certain data set, right? So this is an example that I use for the same. This is a paper from Stanford on deep learning for knee MRI scans. And not to go into details, but when the model was evaluated at Stanford, it gave an AUC of 0.96, the max AUC. And when that same model was taken to a data set from Eastern Europe, the AUC came down to 0.82. But the beautiful part is that when data from that Eastern European site was added to the training set, the AUC came up to 0.91, right? So again, this is the issue of generalizability. How will you test for generalizability if you that's the research piece, right? That's what every radiologist can contribute to. This is just a framework that we use for this. what data was the algorithm developed on? That should be a separate data set. Does the algorithm work on data from a different source? So I used a MR from GE. Does it work on a MR from Philips, from Siemens? Or does it work on a different hospital? Does it work on data from a different country? Here, aspects such as um, race and population demographics, disease distribution start coming in. And lastly, does it work on totally unrelated data, which essentially means I create an AI algorithm using T2 weighted scans, and now I try to run it on CT scans, right? This is a relatively unexplored area, but yes, models are out there that are trying to do stuff like that. This is some of our work. We proposed a framework. We called it the algorithmic audit. This was a couple of years ago, on how do you validate AI algorithms in an extremely clinically robust way, right? And then this is just, I'm very proud to share that the first paper on AI in the Lancet was from India. This was way back in 2018. And this was for deep learning algorithms for head CT scans. Amazing performance. At that time also, along with us, this startup from Mumbai called Cure AI, we did a true independent validation. So again, then imagine the number of papers that can be published just on independent validation, right? This is just critical findings in head CT scans. You can extrapolate this to any body part, any pathology at all. This is a more recent paper on COVID-19 pneumonia on chest x-rays. Again, we proposed a novel validation approach where we showed the performance of an AI model trained on data from 2 hospitals and saw how it performed across multiple hospital systems using different types of annotation techniques. Explainability is the second technical problem that I'll go a little bit deep into. Explainability is this idea of trying to figure out why does the deep learning model say something, right? So again, these models essentially say this is cancer, right? Now, why does the AI system say that's cancer is a very difficult problem, because the number of data points that it correlates in order to get to that one output is infinite, near infinite, right? That's also the beauty and the problem of deep learning. So this was some work that we did where we tried to take AI outputs from a deep learning algorithm, and a doctor radiologist, my colleague Vasant, looked at those and tried to figure out why the AI may have said what it did. Right? It's a very meta kind of article. I'll share the link with the audience in a bit. But this was the first time somebody used this terminology called unboxing AI. But again, work that can only be done by radiologists, right? Nobody else can actually do this. Then the next piece was clinical explainability failure. This is just been published earlier this year in JMS, where we proposed a mechanism for, it is a very manual mechanism, but a mechanism for figuring out true positives, right? Many times as scientists who are attached to AI algorithms, we celebrate true positives, right? AI also found cancer, human also found cancer, beautiful. What we did was we opened up the AI outputs and tried to see, is the reason the AI said cancer the same as the reason the human said cancer? And we realized that many times that's not the case. The AI is looking at some spurious information there and saying cancer, as opposed to the human who is actually looking at a nodule or something like that and then coming up with their diagnosis. So again, something that only radiologists can do, should do every time you're validating AI. This is a paper by some of our friends at Emory University recently. This is bias and fairness of AI algorithms, right? Another extremely hot topic. And this is where, they actually show that AI can recognize race of a patient on chest x-rays without telling the AI what race looks like, right? Very, very dangerous concept, because if AI is taking race into account in a situation where you have not told AI that there is race here, imagine the consequences of the performance of the AI model in the future, right? So again, something that only radiologists can even figure out, right? And most of these people in the authors are radiologists, right? Carpal is used for a lot of this research. This is our product. This is what it looks like. We do automatic statistics, performance reporting, deep dives into false positive, false negatives. We have our bias reports, etc. That are automating a lot of this work. It's not very complicated. It only relies on your clinical intellect. The next piece are ethical issues. Hottest topic of research, nobody wants to touch because also the most controversial. The simple question, who owns healthcare data, right? Again, radiologists can take the lead, should take the lead, because it is radiology data after all that is being used for the building of all these algorithms. Does the patient own the data? Does the healthcare provider own the data? Does the government own the data? Is de-identified data okay? Can you share it with whoever you want? Again, open questions, right? Every institution has their own different guideline. What if there was a universal guideline that anybody could use? Are free data sets okay, right? Is I had cancer, somebody else releases my data into the public, and then somebody in that public is using that data to make money. Is that okay? It's an open question, right? And no two institutions in the world are aligned on that, right? So maybe radiologists can take the lead. Can you make money from my data? I think this is now almost a given that you cannot. But still, there are enough examples around the world. So, but no policy, no guidelines around this. And then there are legal issues, which are possibly the most interesting and most relevant. Who takes the blame for AI outputs, right? Is it the radiologist? Is it the hospital? Is it the engineers who built the AI? Is it the company who's supplying the AI? And who eventually, not doesn't go to jail, but who pays the fine, right? Who covers for liability? Very open questions, and these are research questions because they require tremendous amounts of thought and scientific insight into how these AI models work, right? So in case somebody is interested, we are very excited personally in this stuff. So coming back, to the same screen I started with, each one of these is an open area of research. Pick whatever interests you, but go deep into it and focus on utility. As radiologists, you can start today. There are enough platforms out there that allow you to use and build AI applications. You can reach out to us. We are there for you. Carpal does nothing but connect healthcare providers, AI developers, and health tech providers. And yeah, our whole goal is to connect these two ecosystems. Happy to go into deep into this. So thank you so much for your attention, and I hope that I've been able to excite some of you into getting into some AI research. Thank you.
Absolutely a firecracker of presentation, Dr. Vidur, and it got us all excited. I'm sure I speak for the audience as well. And there was a myth in my mind that AI research only is limited to building algorithms, whereas you opened up an entire box of endless possibilities what we can do with AI research, right from testing to the legal issues. Thank you so much. Moving on quickly to our next speaker is Dr. Daniel Ting from Singapore. He is going to speak on how to understand a paper in AI research. Dr. Daniel is a consultant vitreoretinal surgeon in the Singapore National Eye Center. He's associate professor in ophthalmology with Duke NUS Medical School of Singapore. He has published more than 200 peer-reviewed papers, book chapters, conference abstract, including more than 50 AI and digital technology articles in JAMA, NEJM, Nature Medicine, Nature Biomedical Engineering, Nature Digital Medicine, Lancet Digital Health, Progress in Retinal and Eye Research, Ophthalmology, and many more. Dr. Ting has won many prestigious scientific awards, including Arvo Bert Gasser Award for Innovative Research in Retina, US Macula Society Evangelos Gregoridas Award, Asian Pacific Academy of Ophthalmology, Young Ophthalmologist Award, the Asia Pacific Teleophthalmology Society, Young Innovator Award, Singh Health Distinguished Young Researcher Award, and Singapore General Hospital Young Investigator Award. We are so excited to have you with us, Dr. Daniel. Over to you, sir. Dr. Daniel, sir.
Thanks, Garang. Thanks for your kind invitation and also the kind introduction. So we're really privileged to be here as a retina surgeon, but in a radiology conference. So my name is Daniel. I'm currently working at the National Eye Center in Singapore. Really good to be here to share some of the experience that the lab and my team has learned, over the past 6 to 8 years. On my other hat, also ophthalmology. I'm also the cluster director for AI office for my center. So SingHub is one of the largest hospital system in Singapore. We cater for about 50 to 60% of the subsidized population. We have about 30,000 staff and 4 major general hospitals, 5 subspecialty centers. So in terms of data and things, there's a lot. So there's a lot of interest and things on the AI and the digital innovation space, as you can imagine. So these are some of my financial disclosure. And personally, I'm also sitting in some of the international AI consensus reporting group, steering committee, and personally, I'm also chairing some of the society on the AI stuff, and of course the editorship in some of the digital journals. So hopefully for the next 5 to 10 minutes, I can actually share some of the observations that I've learned and I've seen so far with the audience as well. And we know we are currently in the COVID area, so many interests in the digital health and AI have has sparked. Sorry, just give me a sec. Okay, so for the COVID impact, so basically they have resulted in quite a few different major changes in the healthcare landscape that we see. So firstly, the infectious risk for public and the staff has significantly, increased over the past 2.5 to 3 years. The waiting time in the hospital system has gone up, and a lot of patients have suffered from delayed of the treatment, and partially also because of some of the healthcare workers was asked to go to the front line to fight the COVID-19. And when COVID-19 first started and first hit the world, we were actually thinking whether there's any role for AI or digital innovation to help to mitigate some of the risks for for the public and also the hospital, the healthcare workers. So basically, together with Lawrence Karin, who's the Vice Provost Chair in Duke University back then, Victor Zhao, who's currently the President of National Academy of Medicine in US, and Tian Wang, I'm currently the founding head for Tsinghua, the School of Medicine. We've actually written a piece that's been published in Nature Medicine in March 2020. So this paper has also been quoted by the US CDC then to actually share with the world what we think is some of the potential methodology and also some of the good examples that the world have used to help mitigate the risk of COVID-19 worldwide. So if you look at the digital technology, and I know we're talking about AI, but I just wanted to emphasize that AI can never stand alone, and how AI is actually interlinked and interconnected with the different digital technology like IoTs, the big data, and the blockchain is something that is currently happening worldwide as we speak. So basically, these are some of the examples that we have actually searched and also summarized, and included in our papers back then. So basically, the COVID-19 dashboard from Johns Hopkins, I think this is a super famous one that everyone is aware of. And how do you use AI to predict? So back then, if you could recall, the date that we actually published this paper was March 2020. So at that time, the COVID-19 hasn't quite hit the world yet. So how AI and data analytics was used to build the predictive model, how COVID-19 can spread, and how to prepare the government to actually better fight the COVID-19. I think that was a hot topic back then. And of course, the deep learning technique used for medical imaging, whether it's segmentation, the classification, or prediction. That was something that also been widely used back then. So I mean, this is one of my favorite sites when I give talk, around the world, because I think the reason why we live, how we live our life today. We are in a car, we are, building houses, we have so many cool things to use, is because of the Industrial Revolution. Right now, we are in the fourth, but I would say that we're currently in the 4.5, marching to fifth. So basically, steam, electricity, computing has really revolutionized how the mankind has lived in the past many decades. And AI is a concept that's been introduced. And back in 1950s, it's actually AI term is actually nothing new, right? I mean, the new kids in the block is the deep learning, and machine learning term has been coined back by Arthur Samuel back in 1980s. And back then, the concept of the computer should have the ability to learn is already been established. But the thing that was actually short back then was the lack of the GPU, the supercomputer in the layman's term. So if you talk about deep learning, you have to actually, know these three big figures, right? Yoshua Bengio, Geoffrey Hinton, and Yann LeCun. Jointly, they actually got awarded the Turing Award, which is the Nobel Prize equivalent for computing. So this is the landmark paper I would urge the audience to read if you're really interested in deep learning and AI. It's been currently cited for more than 40,000 times. In the paper itself, it says that deep learning should allow the data to be analyzed by multiple processing layers with multiple level abstraction. So, I mean, if you look at the CNN, and you broadly dissect them into the graphical the manner, and you can actually divide them into 3 layers, right? I mean, so it's the input layer, the hidden, and the output layer. And most of the CNN actually differs in the hidden layers. And over the past, 10 to 15 years, the layers of the CNN has actually increased exponentially. And if you look at the neural nets, they also have shared like a unique characteristics such as the they have a smaller convolutional filters, they have skip connections, and have repeated modules with the parallel connection, and of course the dropouts as well. So I mean, this is a paper, I mean, using the deep learning, but in a gaming space. They have actually shocked the world how the world best Go player got beaten up 3-0 straight match. That was back in 2015 by AlphaGo. But just 1.5 years later, AlphaGo Zero has beaten the same machine using just 40 days. And using an approach called the deep reinforcement learning, and in an unsupervised manner. How is that relevant to what we are doing in the healthcare setting? So people were asked. So the team, the AlphaFold team, that's actually also a spun off from the AlphaGo team, actually use the same technique to predict how the protein can fold and unfold. And this is a paper published in Nature last year as well. So if you ask a human to manually calculate how the protein can fold and unfold, it takes us 13.8 billion years to do that, and it's actually impossible. So with deep learning, there is a way to do it. And what would be the potential implications if the performance actually continue to increase, and potentially we can develop therapeutic targets for the new for new drugs, or we can even modify how the disease can actually progress, or even halt the disease from progressing. So this is potentially powerful. If you look at the global trend, worldwide, the speaker before has actually touched upon a few. So as I mentioned before, the reporting guidelines, when AI deep learning started to hit about 5 to 6 years ago, everyone was using many varying nomenclatures. What is the training data set? What is validation? What is testing? Is validation same as testing? And how do you actually, conduct a good AI retrospective trial versus a prospective trial? Do you need a clinical trial settings to do it? How do you randomize your patients? I mean, these are some of the consort spirit start. Is the conventional way of how research is done, but now we also have the AI extension arm to it. And personally, I'm sitting on the start, decide, and Quadas AI, the international committee on that. So of course, I mean, with the increasing data privacy restriction worldwide, the data privacy and the sharing is getting more challenging. So how do you actually facilitate the cross-border, collaboration to build a model, federated machine learning? I mean, this is one of the new areas that's actually getting increasingly popular. The blockchain is another one. So what about the cybersecurity, the synthetic AI? How do we synthesize the data that we don't have, or how do we actually simulate, some of the training data sets that, for other, for the different medical or clinical settings? So generative advisory network, quantum computers, the hardware. I mean, this is one of the new things. The supercomputers is already very powerful, but quantum computing, it may be another the next frontiers for the hardware to actually power charge the AI, the work. Generalizability, the explainable AI. So again, the previous speakers has actually touched upon some. Medical legal, the implications, last mile implementation, when you want to build and versus when you want to use, actually the consideration is very different, and some of the AI economics as well. So I just wanted to actually share a few slides, to the audience. What is some of the PPT, privacy preserving technology, that the world is currently using now, not just within the healthcare setting, but also outside healthcare setting as well. So FML actually decentralizes the deep learning by removing the need to pull data into a single location. So for example, if you're in US, you're in UK, or in Hong Kong, I'm in Singapore, if I want to actually, invite the three PIs from different countries to build a model, yes, it's possible without needing them to physically transfer their data over to Singapore. So what we need to do is just to build the model, share the weights and things, across with each other, using the federated machine learning. And this is a powerful way for cross-border collaborations in building an AI model. So if for the audience who is interested, please read up the Nature publications on the swarm learning, which is also another modified version of federated machine learning published in 2021 last year. So for blockchain, just a few things. So people always feel that blockchain equates to Bitcoin. Of course, if you look at a cryptocurrency for the past few days, it's actually really slumped a lot. But blockchain itself, the use case, Bitcoin and cryptocurrency, is just one of the many use cases. What is blockchain really mean? And it is actually a distributed ledger technology that decentralizes the control to achieve a trusted peer-to-peer transactions. So it actually really bypasses the need for central authority. And that's also why a lot of the banking system around the world is really fearful about this. And it always begins with a genesis block, and the transactions are stored within a fixed size block. And each of the block is linked to the previous to form an endless chain. So, I mean, if you look at blockchain, I mean, just to finish up on the blockchain, broadly, there's a public chain, there's a private chain, there's also enterprise chain, or they also call it as a consortium chain. So, I mean, those are the big the few big areas in the blockchain that people are currently using now. Of course, the AI applications in medicine is actually spanned across different medical expertise, going from radiology, which is where we are at today, for different medical domains, and ECGs, cardiology, the dermatology, and of course, ophthalmology, which is where I am now. And right now, just to share, I mean, the SingHealth, I mean, the hospital system that we are at, we actually have secured more than 100 mil, the R&D funding, and published so far. I mean, we're lucky enough to publish in quite high impact journals over the past 5 to 7 years, and building more than 10 algorithms in different medical the expertise. And right now, we're also venturing into conversational AI and also like the blockchain domain as well. So, I mean, coming back to the topic that I'm supposed to share today, how to read an AI paper. So as everyone here who have actually written a paper before, we know like a paper can be broadly divided into introduction, methodology, your results, or statistical analysis section, and also your discussion. So I'm just going to try to dissect a paper into the four big different subsections. So I mean, in the introduction itself, really what we are trying to look for is the unmet need, right? So what we are trying to do, why are you doing AI? What questions are you trying to answer? So have you done enough literature review, or are you beating your chest and say that, hey, my AI algorithms or my hospital or my company is the best of all? Or have you actually done enough due diligence to look at what is the state of art that people have already actually described? So, and if you want to propose a new thing, For my advice to people who always, who's trying to submit the papers, try not to say I'm the first, we are the first one who described this, because most of the time when I do a quick search, there's already something on the literature. So I mean, those are the things that you really have to know what value add and what is the unique proposition that your AI algorithms is trying to offer to the public domain. So I mean, the core components wise, I mean, we are actually seeing the trend that different AI groups are using right now. The training, validation, and testing, you can do 60-20-20 split, to 7-20-10, 8-10-10. My analogy is this, right? I mean, the testing part is the most important thing, to look at the consistency and the reproducibility and the generalizability of your AI performance. If you actually split 60-20 or 70-20, it really doesn't matter, so long as your ultimate output, your performance on the independent testing data sets are robust, right? So it's just an analogy, right? I mean, so long, I really don't care where you actually train your basketball in the college and things, and so long as you make it to the playoff, you get your conference finals, and you're like the MVPs. Yeah, I mean, this is the, and then consistently you're performing well, your stats is good. I mean, that is to me is a good basketball player, is a good AI algorithm. So the clinical data sets and technical network is also the other big parts. One is the brain and one is the dictionary. So when many people come to me and say, hey, I have hundreds of images, is it enough to train a model? And different disease will require a different minimally required sample size. So my straight answer is just train with what you have, because it's actually not ideal to wait around and sit around and worry around and say, hey, I don't have enough. And the immediate solution is just try it first and see what you get, and then of course before that, make sure the quality of your data is actually robust before you start passing the data sets to your technical team to do it. So, and having diverse, the phenotype is also very important, right? So having 1,000 normal patients or one patient with 1,000 repeated, the images that's being captured in the same eye within the same time frame is not going to be as robust as having a 1,000 patients, with different phenotypes, of the data. So I mean, those are the data diversity that we are actually talking about. And in terms of the reference standard, so the other words to use is the label. So how true is your truth, and what is the real truth is something that is very, very important for the clinical team to define, because different conditions such as the lung cancer, lung tumor versus brain tumor versus the retina, diabetic retinopathy, they all have different international clinical guidelines to decide that. So I mean, those are the things that would need to go back to the clinical experts. First, define the intended use environment is something very important that the previous, the speakers actually mentioned before as well, and then go from there. So the types of the graders, experience of graders, there's no consensus guidelines to do that, but of course, if it's more experienced and if you have shown the past clinical audit results from your grading, the team that actually has shown consistently is comparable with the gold standards, I think that is good enough. And because if you do not have a good reference standard, is always garbage in, garbage out, right? Yeah. So those are the phenomenon that we should be avoiding. And what about some of the methodology, right? So in the methodology section, you say, hey, I have this image. Most of the time is, people are describing deep learning. So in deep learning, then you have to start going down, what type of CNN is this person is using? Do they have a own technical team to do it? Or are they using something called an auto machine learning platform that can actually be used for anyone who doesn't really have the pre-coding experience as well? And machine learning term, if you were to build a multi-model, so meaning that if you not only have image, but you also have the patients, the risk profiles, the patient demographics and stuff. If you want to build a multi-model, usually you will actually require a machine learning, approach to do that. So, I mean, of course, the genetics wise, I mean, there's a GWAS, there's a whole genome sequencing, there's whole exome sequencing. I mean, there's a different sequencings, they're available in the scientific field right now. So the different, the sequencing also will require a different statistical approach and also the machine learning approach to do it. So when we actually look at, the AI algorithms, it's not about just the CNN, right? We are talking about the AI operational flow. So, I mean, CNN just make up one of the very basic part of the entire AI operational flow. So what do I mean by that, right? So, I mean, just imagine you're a patient coming into the hospital. And the first thing that they will go into is to actually, they arrive in the doorstep, in the entrance. First thing they'll go for registration counter. And after registration counter, they'll be given the waiting time. And, if they need to actually, go to another departments to check for the blood pressure first, and then to take a echocardiogram if there's in a heart center, or, if they have to go for dilation. So those are the thing we call the clinical flow. So in the machine or in the AI operational flow, is the same thing. If I actually take a chest X-ray or CT head, so the first thing is how how does the system actually determine whether this is taken from the CT or versus the MRI, right? So this will be the device recognition, the flow that you have to set. And what about, is it the right lung or left lung? Is it an AP, or is it a lateral, or is it a PA, right? So, I mean, this is also another flow that you have to inject. What about the image quality? Is the image taken properly? Is the patient's actually breathing in, like the lung or the thorax is expanded enough for the X-ray to be done, or is patient, lying on the bed for all those portable ones? So, I mean, those are the different things that, you have to actually take into account. What about if your image is slightly being rotated? How do you actually take those into account, right? I mean, the image rotation, so those are the different types of the image pre-processing steps that one have to actually be aware of before you actually even send all these images into your CNN for analysis. Then, of course, when the CNN has done the analysis, the output, which is what you set at the upfront, what is 1, what is 0, what is if you're multi-class, right? That's binary. If you're multi-class, there's a multi-class settings. And of course, we talk about explainability. Once we actually build this CNN, then what kind of visualization techniques are we going to use? Soft attention map? Are you going to use ablation analysis to do it? Or what about the the grab cam or soft some of the integrated gradient method? So I mean, those are the design thinking you need to have in order to build an AI system. So of course, when we actually look at finally you get your results, and this is what the FDA, US FDA has actually advised, right? SAMD, software as a medical device. So you actually AUC, in my mind, is never going to be enough, because I mean, AUC just tell you overall performance, but that means a lot of things. And if you were to deploy it in a clinical setting, you always have to preset your operating threshold in your training set, not using your testing set and set your operating threshold, because you do not have the opportunity to shift the goalpost when you freeze your AI algorithms to be deployed in a real world setting. So those are the different things. And of course, when I look at AUC sensitivity and specificity, I always look at the 95% confidence interval, because that actually shows me how tight your AI algorithms is in the different data sets as well. And the generalizability, I mean, the more data sets that you can actually bring in, the more closer that you can actually show that it simulates the real world clinical data sets or the patients, the more robust it will be. Yeah, so of course the AI adoption, so moving on to the discussion section, then we have to know, hey, I mean, I have these AI algorithm. Have you thought of where to deploy your system? Is it cloud-based? Is it API set in desktop laptops, or is it within the imaging devices? What about the IT ecosystem, right? Who will be the users? Is it going to be the specialist, or is it going to be a general medical specialist, or is it going to be general medical practitioners, or even non-healthcare practitioners to do it? What about the real world patients? I mean, setting an intended use environment is one thing, but when you're actually using it in the real world settings, is it for all age group patients, or is it for selected, the age group patients to do it? What about the, the level of automations you want to do? Is it going to be fully automated when there's no human in the loop? Whether is it going to be a semi-automated when your AI is going to take care of a portion of your entire clinical load, and then the other one will be actually handled by the human? Or is it going to be 100% assistive, meaning that even though the AI is doing the first read, but the human is the one that making the final diagnosis on 100% of the workload. So I mean, those are the three main different categories you have to actually be thinking about. And of course, always, I can't emphasize this, well enough, illustrate the limitation of your AI system, because nothing is perfect in the world. The more you can tell me what is the weakness of your AI system and how can you rectify them in the real world setting, the more appealing that is to the to the editors in the journal. So, I mean, some of the emerging technology I just want to touch upon before I finish my talk. I mean, the 5G, 6G, we talk about hardware, software, but I mean, as I mentioned before, AI can never stand alone. You talk about cloud, you have to talk about telecommunication, the system. So we are currently in 4G, 5G era, 6G is underway, and this actually has power charged a lot of the telehealth. While you can do store and forward, but you also can do the live, consultation or live treatment. So this is one of the study that I actually had the opportunity to participate, how people are using 5G to actually provide the teleretinal lasers to the rural patients in China. And the quantum computing is another one that I actually mentioned before. We think the supercomputer, the GPUs, is powerful enough. What a quantum computers can do in 3.5 minutes, it takes a GPU 10,000 years to do it. So this is a potentially very powerful hardware that the world is really waiting hard to actually see what it can do. And so this paper is published in Nature again, 2018. You realize that the paper that I use today is all either from Nature and Lancet and things like that, because I think these are some of the landmark papers that is happening in the AI field. This is usually give me like the first, the filtering to actually for my own reading. And for those who are interested, someone actually asked me before, I don't know where to start. I think having a read, searching in Google from the good resource, I think it's a good start. But of course, I'm not saying that the papers that published in the good journal means that it's going to be 100% correct. No, but that is actually a good start for someone who actually want to look for the nice paper to read. And so, of course, the metaverse, I mean, this is another, the big domain that, Facebook, of course, changed their name to Meta. But whether or not this is something, is a real need, is it a hype, or is it a potential use case? I think the time will tell. And how is this going to be very different from the AR, VR, or MR? So augmented reality, virtual reality, or mixed reality. And metaverse, as I'm not sure for audience who don't know about this is also again in the virtual reality, the space, but this time around you get to create your own avatar. I mean, so this is a slight difference between the different things. And with this, I would like to thank the organizer for the kind invitation to share. Thank you.
Thank you so much, Daniel, sir. And it was really an inspiring talk. You touched upon all the intricate details of AI paper and made it extremely simplified for us who wish to understand the AI paper. You also touched on the future of AI and technology, right from hardware, software, everything. Thank you so much, sir, for your wonderful thoughts and wonderful lecture. Moving on to our last faculty speaker, Dr. Chang Min Park. Dr. Chang Min Park is a full-time professor at Seoul National University Medical College and a faculty member of Radiology Department of Seoul National University Hospital. He is graduate from Seoul National University Medical College and completed all the postgraduate training at the same university. He serves as a board member for multiple medical societies, including the Korean Society of Radiology, the Korean Society of Thoracic Radiology, and the Korean Society of Artificial Intelligence in Medicine. He also serves as an AI Special Program Committee Chair for 2022 Asian Oceanian Congress of Radiology and Scientific Committee Chair for 2023 Asian Congress of Thoracic Imaging. We are really grateful to have you, sir, on board for the lecture. Welcome, sir. Over to you.
Thank you so much for your kind introduction and having me here. Wait a second, I will show my presentation material. Can you see it?
Yes, sir, we can see it.
Okay, I will start. Actually, my today's topic is the steps involved in AI research projects. But the problem is that my two excellent previous speakers, beautifully and excellently summarized and talk about my topic. But still, I think this topic is really, really important. So I would like to reiterate this topic in my own language as the clinical radiologist. This slide summarizes my topic actually. Generally speaking, AI research starts from definition or defining the use case of AI. Use case means the purpose or clinical indication which the developed AIs are to be applied for in the clinical practice. After defining the use case, we need to prepare for AI development. This step typically includes data collection step and the data curation process, including data labeling and annotation process. After data preparation, we can start modeling of a specific AI algorithm. It can be a chest X-ray AI or chest CT or kind of like abdominal ultrasound AIs. After model development, we need to conduct kind of a performance test, including internal and external validation tests. And we often need a performance comparison with the current champion of a specific domain. For example, as a radiologist, just a radiology, radiologist can be a kind of a current champion of our field. Once performance test shows a kind of a satisfying result in an experimental setting, we can safely move to the next step, the testing in the real world clinical settings. It can be a retrospective study or it can be a prospective study. Actually, the more strictly and meticulously the test will be done, the higher the quality of your research and the chance of your paper being published in high-profile journal would be, I think. Actually, all AIs do not require legal approval process by governmental authorities, but this process is often necessary in reality before the clinical implementation of radiology AI products. After the implementation of AI in the daily clinical practice, we can evaluate their real-world clinical value or usefulness through kind of a post-implementation or post-market survey research. Actually, this is a brief summary of the steps involved in the AI research projects, roughly speaking. From now on, I'm going to take an example with my chest X-ray AI research. As you know, chest X-ray AI field is currently one of the hottest topics among radiology AI research. Other than chest X-rays, the breast mammography, the breast cancer detection using breast mammography or lung nodule detection model using the low-dose CT lung cancer screening or kind of a triage system, AI-based triage system for the brain hemorrhage or stroke using brain CT will be such a hot topic in the radiology AI field. You know, actually chest X-ray is the mainstay for the diagnosis of many thoracic diseases. They are the most commonly performed radiologic tests, accounting for 25 to 50% of all radiologic studies. Roughly speaking, 2 billion of chest radiographs have been performed worldwide every year. However, as you know, chest X-ray is not a perfect diagnostic study and definitely has limited diagnostic performance. Chest X-ray has been notorious for their reading errors and has long been one of the culprits for radiology malpractice legal suit, along with the mammography. So since the 1960s, this modality has been one of the main topic for computer-aided detection, assisted detection and diagnosis field, CAD field, and recently became the main target for deep learning application in radiology field. Our research group actually has been focusing on this chest X-ray AI research since 2015. And we have developed and validated 4 chest X-ray AI CAD systems so far, such as automatic detection system for malignant lung nodules, active pulmonary TB detection model and major thoracic disease detection model. And recently, we developed 10 common radiologic abnormal finding detection model on chest X-rays. Among them, I'm going to cover the AI model for detection of major thoracic diseases today. For this research, we defined the major thoracic diseases. Actually, this is kind of an arbitrary term. We invented this term based on the kind of a clinical relevance or clinical importance or disease prevalence and their detectability or visibility on chest X-rays. Finally, we included 5 disease entities for this model. It included lung cancer, pulmonary metastasis, tuberculosis, pneumonia, and pneumothorax. Actually, our AI model was developed to assist physicians to detect these 5 disease entities on chest X-rays. For model development, we collected approximately 100,000 of chest X-rays from our hospital. 15 radiologists took part in this data labeling and lesion annotation process, and it took almost 1 year actually. After the data preparation, we trained AI model, AI software using DenseNet architecture. Actually, at that time, the state-of-the-art AI architecture. The developed AI model actually provided 2 very simple functions, very simple actually. One is to class or categorize whether an input chest X-ray is normal or abnormal. And the other is to inform where the abnormal lesions are located on the chest X-ray. After model development, this software was validated through internal and 5 times of external validation tests, including 1 site of a French hospital. Performance testing is actually very critical in AI research because, as you know, deep learning technology is very vulnerable to overfitting phenomenon and shows a substantial weakness in generalizability. In our case, internal and external validation tests showed excellent and consistent performance. Consistent performance can be a good point, I think. For performance comparison of AI with domain experts, in this case radiologist, we conducted a kind of observer, reader performance test with 15 physicians, including 5 non-radiology physicians, 5 general, but both certified radiologists and 5 the chest radiologists. This left ROC plot is for classification performance task, and the right one is for lesion localization performance. The red line is for non-radiology physician, and blue line is for general radiologist, and the green line is for chest radiologist, and the black line is our model. As you can see in these 2 ROC plot, our developed model outperformed all the physician group, both in terms of classification and the lesion localization tasks. Furthermore, this AI CAD system showed a kind of a performance boosting effect when used as a second reader. When assisted by the AI, the average performance of physicians improved from their performance from 0.881 to 0.934 in classification task, and from 0.853 to 0.910 in lesion localization task. When we investigate the details, the performance boosting effect was the largest for non-radiology physician group, the least experienced, and the worst performance reader group. In addition, when used as a second reader, chest X-ray AI substantially reduced inter-reader variability through its performance boosting effect on less performance group. Along with the model diagnostic performance, actually clinical AIs should be checked for their reproducibility and calibration performance as well. So we conducted this study, and we found that the mean difference of the abnormal scores, I mean the probability scores produced by our AI, was around 2%. I think a very reproducible model. And the test-retest variation was negatively associated with lesion size and lesion conspicuity. It's very natural and reasonable, I think. The model's calibration was not quite bad as well. Its mean error was less than 0.1, and the maximum error was less than 0.2. Now is my question. Can you safely guarantee that our model, AI model, will work well in our routine clinical practice? Actually, at that time, we did not think so, because the real-world clinical setting may be substantially different from those validation data sets, especially in terms of the disease prevalence and the disease spectrum of abnormalities encountered on chest X-rays. So we conducted multiple sessions of clinical validation studies using real-world clinical cohorts. We checked the diagnostic performance of our model for emergency department visit setting, lung cancer detection, performance task in a health screening or health checkup setting, and the TB screening in a large TB screening population, and so on. Here's one of my researches. This study was to evaluate the diagnostic performance of our model for patients visiting the emergency department and receiving their first chest X-rays in our hospital. The prevalence of an abnormal chest X-ray in this study was 22.6%. The overall diagnostic performance of our model was, I mean, the ROC value, the AUC of this ROC was 0.949, which was still excellent, but a little lower than those confirmed or checked or resulted by the previous experimental studies. The algorithm showed much higher sensitivity and negative predictive value than our on-call reading doctor. In our hospital, the senior radiology residents read the chest X-rays, but the model's AI model's specificity and PPV, positive predictive value, was much lower than our residents. To investigate whether this AI algorithm can improve the diagnostic performance of reading doctor, reading radiologist, the residents as a second reader, we provided the algorithm's results to the on-call resident back, and we asked them about whether you will change your initial reading or not. In this reading session, the sensitivity and the negative predictive value of our residents were significantly improved. But unfortunately, their specificity and the positive predictive value were significantly decreased. In reality, everything does not go optimistic, and good things accompany bad things. We need to think more about the kind of a specific or sophisticated strategies to solve this kind of a diagnostic trade-offs. After legal approval from Korean government, we have implemented this AI system, chest X-ray AI system in our hospital in early 2019. This video shows how it works in our reading practice in our hospital. And as you can see in this plot, this AI system is increasingly utilized in our hospital as time goes on. Recently, we have finished a kind of a post-implementation survey or post-market survey study to evaluate whether our chest X-ray reading practice will really improve with this kind of AI implementation. And fortunately, after the AI tool implementation in our hospital, the diagnostic yield of metastatic lung nodule detection on chest X-ray and the sensitivity and accuracy of pneumothorax detection through chest X-ray was significantly improved. I think it's very good and happy news. Now let me talk about the AI-based the new service, case triage service for urgent diseases. This screenshot is for our PACS, the PACS worker list in our hospital. In our hospital, all chest X-rays are now analyzed by AI software in advance, and they are prioritized based on their clinical relevance. We determined the pneumothorax and the pneumoperitoneum as urgent findings for kind of expedited reading. And now chest X-rays with those two disease entities are flagged and are located on the top of our PACS work list for expedited reading. I think this kind of a new service can lead to timely diagnosis and early treatment initiation for this kind of urgent diseases. Through the simulation study, the turnaround time, the time between the image acquisition to image interpretation for this kind of critical diseases was significantly shortened by 5 times when we use this kind of a prioritization function. A specific disease entity, in my case, pneumothorax or pneumoperitoneum, can change depending on your hospital or your country's major concerns. But definitely, this kind of a service can be a game changer in radiology field. If you are interested in kind of a generalizability or building up more strong clinical evidence for AI, radiology AI tools, I think you can conduct international collaboration research. In our case, we conducted several international collaboration researches, including this TB screening research using our AI model for Brazilian prisons setting. Actually, this is my last slide. You can check the steps for AI researches here again. And I would like to wrap up my talks by commenting the future of radiology and radiology AI. Frankly speaking, I'm optimistic and believe that radiology practices augmented or supported by AI technology can improve our diagnostic performance and patient clinical outcome, and the patient hospital experience, the quality of life of caregivers like radiologists, and at the same time, the healthcare cost reduction, eventually leading to our radiology practice and healthcare innovation. Thank you so much for your attention. Thank you.
Thank you so much, sir, for a detailed analysis on different steps involved in AI research. And it was really a great experience to have a radiologist view on what are the steps involved specifically in radiology research, sir. We finally understood. And I must thank all the faculty members. The talks are so neatly overlapped that we get a good revision as we try to grasp on the different concepts, because this is a very difficult topic. And I am sure I speak for the audience that everybody has understood all the talks well. Moving on to the panel discussion. Before that, I would just like to introduce our panel. Everybody knows our speakers. There are few people on our panel. Dr. Hemant Patel, sir, he is the ISR Executive Counselor, and he is the Chairman of Education Committee of AOSR. He is the National Past President of IRIA. Dr. Evelyn Madam, she is the current President of AOSR and past President of the College of Radiology at Malaysia. And she has 20 years of contribution in healthcare in Malaysia. We have Dr. Sher Hang Tan, sir, who is the council member of AOSR and the chair of the Emerging Trends Committee. He is the current president of the Singapore Radiological Association. And we have with us the legend, Professor Huang Hung. Sir is the chair of Asia Safe AOSR. He's a medical physicist closely allied with radiologists and oncologists. Collaborative research in patient dosimetry, computer application, and issues of AI such as ethical, legal, authentication. We are so fortunate to have all of you here with us. I welcome you all on board. We would like to begin with few questions for the faculty, which we have got from the audience. And the first question is for Dr. Daniel. It is from YHC Taiwan. And the audience is asking, what is the major weakness of current AI technology, medical imaging in terms of economics?
I think like if I understand the question correctly, what in terms of the major weakness of the clinical adoption, I mean, looking for return of investment, I think if I understand the questions correctly in this way, one of the things that I mean, the IT deployment cost is actually very expensive, right? I mean, so if you want to do AI, a lot of things is actually an additional cost. So I mean, how do you then actually come up with a strategy to make up for such deployment costs, right? Is it going to be reducing the manpower, the radiologists that's needed to read the scan, radiographer to take the scan, or and so on and so forth? I think this is one of the things that the business model of how the AI solution can achieve a sustainable financial model. I think this is one of the key the issues with many hospital system in deploying AI, right? I mean, that's number one. Second thing is the AI. Usually, if you were to build AI solutions, the threshold we usually put it slightly lower, just purely because the false negative rate, I mean, of missing, say, like a lung tumor or like the heat tumor is going to be of medically significant, right? But in doing that, you are compensating for a higher false positive rate, right? So Vito actually mentioned about the false positive thing just now. So if you look at the health economics, just from a very conventional manner, right? The one thing that will drive up cost is the false positive rate, because for each of the case that you're supposed to be read in the community, for instance, now you are actually, because of your false positive referral, they all have to be read by the medical specialist. So in terms of the clinical service, the fees, you will actually make it like 2 to 3 times more as compared to the previous model. So I mean, those are the things. If you actually run like a torpedo diagram on the Markov model, you will find out that the top bar, the longest bar, would be the false positive rate. So those are the two main thing, right? The cost of deployment for your AI system. How do you get it integrated within your digital ecosystem? Number two is how do you handle the false positive rate? That would be, I wouldn't say it's a weakness, but I say it's the major determining factor whether your AI solution can be successful or not. Yeah, thanks.
Thank you so much, sir, for beautifully answering.
Dr. Gaurav, if I might just add 30 seconds.
Yes, please.
So great point brought about by Daniel. So we are actually attempting to address that false positive issue by running multiple AI systems that do the same thing, that are trained in different parts of the world, and ensembling their results to say that, so for example, in a situation like mammography, if a mammogram is run through 3 of the world's best AI systems, and all 3 say no cancer, right? Do you really need a 4th pair of human eyes to verify that fact? Or is there a future scenario where, you can just let that go? Something like what happens in the world of pathology and lab medicine, right? Pathologists are signing out 5,000, 2,000, 3,000 reports a day, not looking at all the slides, only going by the edge and figuring out the edge cases and looking at the edge cases. So that's how, that's a crazy kind of thing that we are attempting to do, is run, 3 of the world's best systems. And if all 3 say the same thing, you go with it.
Thank you so much.
If all 3 systems say the same thing, then are we looking at suing your 3 systems if anything goes wrong? Because at the end of the day, the radiologist has to clean it up, right?
It's the same as what happens in pathology, right? You need to have the quality management systems in place, and you need to increase your liability insurance appropriately. but the beautiful part is that you can actually democratize technology, right? The reason every street in India has a pathology lab is because you put in blood, you get out a number, right? Now that brings costs down, that pushes volumes up. So as a radiologist, you might be reporting 500, 700 scans a day and getting paid for 500, 700 scans a day, as opposed to 50 or 100, the case may be today. So this is, it's another active area of research, right? How can we get to autonomous AI where we are sure that a particular finding is either present or not present?
Thank you. We have a question for Dr. Park, and it's a question from Evelyn Madam herself. The AI computer-aided detection for chest X-ray in your hospital, who pays for it? The hospital, the government? What is the payment model that exists in South Korea?
Yeah, actually, the payment or reimbursement system is very, very critical and important. But frankly speaking, even in South Korea, we do not have any example for reimbursement from our insurers. So in our case, actually, hospital bought our AI systems. But actually, I think if in the future and we can confirm that the clinical usefulness of our AI system for patient care, I think it could be reimbursed by the insurer. I mean the patients. As you know, actually there are several payment system, United States or Japan, and actually the two countries have different payment system. In the case of the U.S., there are two systems. One is the NTAP, the new technology add-on payment, or the other one is kind of the different system. And usually we are now focusing on NTAP, the new technology add-on payments. And there are examples like echocardiography and the kind of the triage system of brain stroke, brain large vessel occlusion model using brain CT by AI model. But the NTAP system is kind of a temporary system. When my memory serves me correctly, it's just a 3-year temporary system. During the 3 years, the AI developer or the company will get how useful the software is. Then they will hand in that result to kind of the government. Then the government can determine whether this system can be properly paid or just to quit, just that kind of temporary system. And in the case of Japan, actually, Japan has different system. Japan's system is kind of the additional payment system. If hospital set up kind of AI-based clinical service, they add some kind of money to that hospital. It's quite different. But in the case of South Korea, actually, we did not determine yet what kind of pay system we will do. But I think time will solve that problem. Thank you.
Sir, we just missed on wonderful views of Professor Hung, and I would request him for his comments on the previous question. I just missed his message.
Okay, thank you. Basically, the question asked was the deployment of AI systems in the real world setting. So far, our discussions or meetings is amongst the professionals, amongst the specialists or the computer science people or the industrialists, the commercial people. But there should be a meeting or summit to bring all the stakeholders together, including the funders, the regulators, taxpayers, the members of public. They have different expectations. They have a lot of misconceptions what AI can do. What we read a lot, all the hypes, such a company or this research group have shown 98% accuracy and all that hype, but in reality, it's not there. So that also result in some disappointment. So I would like to encourage, like from our group, Aosr, to initiate such multi-stakeholders dialogue discussion that will be a way forward And also remember the A's, whatever system we do or we develop to be available, accessible, affordable, right? These are the WHO or the A's, affordable, accessible, available. If I may add, it should be adaptable, right? I can see all this. We have to adapt the system to various countries, very computer systems, adaptable. That would be good. Thank you.
Thank you so much, sir. There is one more question I personally had for Dr. Vidur, and he is full-time into this AI research and everything. So I wanted to ask him, how lucrative is AI research? What is the fame? What is the money involved if somebody wants to get it into AI research full-time?
That's a very interesting question, Dr. Gaurang. And I think so. There are two avenues for it, right? One is academia, which I think is fairly well established, and even in a country like India, in an academic hospital, you can write grants. You can, of course, your salary is fixed. At least in India, that's the way it operates. So one option is academia. I'll talk a little bit about the non-academic side of things, because we work with so many different startups and big companies across the world that have extremely open minds and a lot of opportunities for radiologists. So I'll start with the big companies, right? So all of us know the GE, Philips, Siemens of the world. All of them are almost all the time recruiting radiologists full time. And these are either research roles or product roles, right? Where you have to contribute your clinical knowledge and help translate something that has been built by hardcore researchers there into clinical practice. Now, you may not be allowed to publish a lot of that work, because naturally, they want it to be confidential and they don't want people to know about it, so on and so forth. But it is one of the most impactful ways. Like, something that you have built can potentially go into every X-ray machine on the planet, right? So that's the big companies. There's second type of big companies, the Amazons, Azure, Microsoft, Googles of the world, that are also constantly recruiting radiologists. In fact, we've had people from Stanford go to Amazon recently. Matt Lundgren is an example. Folks from Duke. So it is very much these companies, these large tech giants, are also trying to build systems to help make radiology AI easier to make, right? So that we can go onto their clouds and make our applications there. The third type of category of company is startups, right? Startups need radiologists. I still feel so disappointed when I see, three engineers get together and not have a doctor as part of the core founding team of their startup, right? You cannot build clinical technology outside a clinic. So you need to have that input. And financially, honestly, Dr. Gaurav, startups are probably the most lucrative, because if you get the opportunity to get equity, get ESOPs, even if you get $100,000 of ESOPs, that can translate into 10 million, because the whole game of a startup is how do you go from 1 to 100, right? So several opportunities exist. I'm sure any radiologist, you go on LinkedIn, you say I'm looking for a role within a startup, you will have like 100 people reach out, and it's there's a lot of excitement around that space.
That's great. That's great. I also have another question for Dr. Hemant Patel, sir. Is there?
Yes, Gaurang.
Yes, sir. So, sir, it was my question, and Dr. Evelyn also has her perspective, and I'll combine both, because you are. I have seen you rise from as a national president to the Aosr role, now in the ISR, and you have a bird's eye view of what is going on globally. Whether AI is a friend or foe, so whether AI will end up as an application in part of our equipment software that the hospital pays, and it serves the patient better, or how does AI end up as in 2023 and beyond?
Gaurang, it's a very interesting question. But on this outset, I would like to congratulate all the speakers, Vidu, Daniel, Chang, for great insight in the AI, and to you as well and all the AI committee members, and Evelyn for executing this wonderful seminar. It's a, it's a kind of the ghost, which is hanging around since many years. Whether AI is it's a friend or it's actually enemy of radiologist, and this will completely replace. There won't be any need for radiologists. In fact, in 2016 and 17 around, there were many medical, school graduates. They were wondering, should we take admission in radiology or not? And there was some decline trend in getting into the post graduation in radiology, just because that eventually radiology will be taken over by computer and AI, just like the pathologist. So it was to that extent that apprehension and anxiety was there. But one thing, this is, it's already, now established and proven that it's not going to replace the radiologist. In fact, radiologists will be always there, not today, but in the future also, to validate any diagnosis done by AI system or computer based any technology. The thing to understand from, all the medical fraternity member is that, role of AI in radiology is not only for the diagnosis. See, it's helping in the entire chain of the radiology care, starting from the patient registration to give the positioning of the patient will be automated by with the help of the AI, depending on the weight of the patient, depending on the age of the patient. It will have the role in the radiation modulation as per again the age and the weight criteria. AI will automatically detect what is the, exact and the precise dose of the radiation has to be there. Same for the contrast media also, how much to deliver with the help of the AI. Once patient is taken for the scan, then how many sequences exactly we need in given clinical scenario is now defined with the help of the AI. So then after, once we are getting the images, then the labeling of the spine and many other things automated, done with the help of the AI. Till this point, there is no diagnosis has been done with the help of the AI. Now the AI will tell us that, these are the likely possibilities, doctor. So you kindly look at all these things and correlate with clinical and your judgment, and finally you put your comments and the diagnosis. So this is more of a kind of helping to the radiologist at each and every step, as if we have got the mini robot now at each step, what we are doing in our day-to-day clinical practice. One thing where AI is far superior than all radiologists, what we are doing practice, is that for any numerical stuff, it can count the number of the nodule, size, volume, just in a fraction of second, for which, we have to spare the comparison and everything, sometime so many minutes or sometime hours together to do the comparative studies, which will be really easier with the help of the AI tool. One more important aspect from my point of view is that to do the clino-radiopathological correlation, now with the help of the AI, it can get the, sequential data of the biochemistry, pathological studies and the clinical things, and then it will combine it with the radiological stuff. So it's having the more precision. And I'm sure that, now the board meeting, which is tumor board meeting happening, as on today, after few years there will be the AI module will be there inserted in all the meetings, which will give us the, even better patient management care also. So simply AI is a tool which will help us to achieve more accuracy, more precision. In a simple analogy, it is like the Google map, so which keep guiding you every time, where usually you are reaching at the right point at a very fast pace, at a very right direction, and with the more precision. So definitely it's a friend. And the good thing that the radiology community has adopted with the open arms, and that is the reason now why the radiology is leading in the AI as far as the healthcare industry is concerned. Thank you, Goran.
Thank you so much, sir. Thank you, sir. We have few questions from the audience, which I would like to ask the panelists, and please feel free to share your views. There is one question from Priyesh, who is a PhD from the University of Illinois. Curious if there are efforts put to incorporate trustworthy AI in radiology using techniques such as uncertainty, aware Bayesian, or probabilistic interference that can lead to confidence-aware prediction. Very critical to know prediction confidence before any decision making.
I can take a shot at it. So essentially, Priyesh, great question. This is an active area of research. I didn't bring it up because it's not right now radiologists that are working on this. But the whole domain of, to put it, in layman's terms, the whole domain of figuring out whether an AI system should run on a particular input or not is a very active area of research. I personally believe that it is the future. In fact, there is this paper recently published by Stanford called Checks Stray. So CHEXSTRAY, which uses out of distribution detection systems to figure out, the uncertainty of a prediction that is going to be given by the AI. So then you can kind of set a threshold on that and say that if an OOD model is saying high probability of out of distribution, then you don't give an AI output and thereby avoid a false positive or a false negative at the get-go. So thereby, increasing your performance. So I don't know if I think that is what Bayesian inference means, but at least OOD is a very active area. Two people that are working on this is one guy is a guy called Arjun Soin from Stanford. Another guy, lady is Imran Banerjee from Mayo Clinic. So you can reach out to them. I'm sure they'll tell you much more than I can.
Thank you so much. There is another question, that is, what are the approaches towards digital pathology and AI adoption with more focus on number of increased slides? Example, how would one design a federated model on digital pathology? Dr. Daniel, Dr. Chang.
Perhaps let me take this. Yeah. I mean, I think the general principle for either path, for radio, or for retinal imaging will all be largely similar, right? I think like the question is how we could actually get, I'm not sure whether they're actually asking about the sample size issues. Hence, you need to actually have one cut, but with one more slices, or you will need to actually build a federated machine learning model with the different the sites, because this is usually where the federated machine learning is will come in handy. So I mean, coming back to pathology, the specimen, of course, they actually have their own unique the problems, right? I mean, the way you cut it and how do you actually process the specimen, and you also have a different the staining methodology, and of course the viewing system from a microscope also, you can actually differ from companies to company. And of course, the magnification is also another thing. So I mean, those are the few like the different specs. I know this is a radio the conference, but I mean, this is a very good questions, because this is one of the things that actually is quite highly relevant to the different medical imaging field for other specialty as well. So I mean, if I were to actually, the first unmet need would be, if I only have 200 patients biopsy specimen, and how can I increase the sample size? I think, I mean, having a different cut with very intensive labeling, I think that would definitely help. So I mean, to answer the question, yes, I mean, increased slides definitely help, but you have to you have to cut it in a very unique manner, not like the same angle. You cut it multiple times, but you actually have to come in different angles to do it. That's one. Second is, if you actually trialing that, that's actually is not enough, then reach out to the different sites. Not many countries, I mean, okay, of course, like most of the countries worldwide, we're very reluctant to share the specimen, but there are still some countries within their rules, so long as the data is de-identified, they are okay to actually share. So I think this is, it's either you could actually build a federated machine learning model if your team has the capability to do it, or you could actually reach out to the collaborators to ask them whether they can send you the slides to do it. So that's second. Thirdly is to actually use the pre-trained CNN model. I mean, this is some of the common methodology that any AI research group will actually always use, right? So the third one is to actually use the pre-trained model. So if you actually download all the off-the-shelf CNN network, right now they're all pre-trained using the ImageNet classification. So I think the other thing is, if you want to actually go with some of the industries, the free the model, you can actually go and try some of the software stacks. For instance, NVIDIA, they have a Monai, the software that actually do segmentations and things like that. I'm not very sure whether they do pathology, but certainly for radiology, they do. So, I mean, you can actually download them from the GitHub. So, I mean, it's a pretty powerful thing to actually also try to see whether you can actually increase. Of course, then the fifth one will be the synthetic AI. So, I mean, can you actually generate models? Can you actually do mirroring, right? I mean, so you actually flip it around, you rotate it around. So there's a lot of different methodology that how people actually do data augmentations to actually, increase the robustness of the AI model. So federated machine learning is just one of the many methodology that people use. So I hope that actually answers the questions. Thanks.
Thank you so much. And next question I would like to ask Dr. Chang, because we have already discussed the economics and he would be better able to put more light. So the question is, should AI company or hospital support insurance for a false result, AI result? Who should pay for the insurance? The company?
Yes, I think the question is very interesting, but debatable. It depends on the system actually. But I think in my humble opinion, regarding the radiology and radiology-based AI practice, actually, who are responsible for that kind of practice? I personally believe that radiologists should take responsibility. AI is just a kind of just tool to support and augment our radiologists. So determinants of the radiology practice are definitely radiologists. So I think even in the false diagnosis cases, the final determinants of that decision is radiologist. So I personally think that the such system can be reimbursed because it's kind of a radiology practices. And actually, this question is leaded to kind of the legal liability on the AI-based practices. Even in that situation, as I already said, radiologist is the final determinant. So the radiologist should take responsibility. And I think this approach is not the bad thing from the side of radiologist, because we are control all the issues related to radiology AI conditions. So I personally think that we radiologists be very active on this kind of the policy determination or clinical utilization or clinical application of these kind of AI related practices. Thank you.
Thank you so much.
And can I add on to what Dr. Park has said? So I want to throw out to all the panelists and our speakers is that do we foresee, since AI is actually a tool, I agree totally with Dr. Park, is that in the future, would AI applications just be integrated into all our, whether it's the microscope or whatever it is, our equipment, so that it is actually the hospital who buys it or the person who owns it buys it, because it's going to help with patient outcome and it just becomes our extension. It's like our eyes, augmented eyes or whatever. So just throw it out, because I feel that might be a solution to all these reimbursement issues, assuming that all this works out to the benefit of the patient and ourselves working more efficiently.
Absolutely correct, ma'am. I had a question for you as a leader of AOSR, ma'am. What do you think is the role in integrating countries across AOSR for a research? How can we go for a multicentric AI product, or how can we do that?
Okay, there are two questions here. First, I asked the panelists. So anyway, maybe we listen to what everybody has to say about having that tool as an extension. And then once we have that tool as an extension, then multi-center and multi-country collaboration becomes easier, because right now there are, number one, payment issues. Number two, resource availability, because we have countries across our region which are of different resources. We are not Japan if we are in Vietnam. And likewise, India versus, Singapore, we are looking at very different population and resource limitations sometimes. High resource versus low resource. We definitely can help with the federated machine learning. because I think even for a private center where I come from, they are very hesitant in donating data sets, even if de-identified for learning purposes. Because at the end of all this, if everything works out well, somebody is going to commercialize it. Am I right, Vidor? That's why we are doing all this for commercial reasons. So
But
yeah,
nothing will be commercialized. But ma'am, nothing will be commercialized if it doesn't help and if it doesn't work.
So I don't know. I think our speakers may be even better positioned as because they are actually actively researchers in AI. How can we have multi-center collaboration so that our data that AI is used on can be better?
Let me take Evelyn. Let me take your questions. Yeah, I think there's two parts to your questions. Right, one is how do we, deploy AI? Whether is it going to be embedded? I mean, so I am not sure whether you guys saw one of the slides that I did. I think the point of deployment is actually quite important because I mean, right now. There's a few different the clinical service model, also business model for AI solutions. One is called SaaS, software as a solution, right? So it's like a Microsoft, you sign up for subscription, you pay per use. And the question is, if you actually have to do that, then where shall you actually deploy it, right? I mean, and then the question comes down to whether your AI solution, is it an assistive tool or is it a screening tool? If it's a screening tool, then the users also, again, is different. Your user, if you're screening tool, your user will be a non-specialist user. I mean, say, for instance, if coming from ophthalmology standpoint, if I were to actually develop an AI solution to screen for diabetic retinopathy in the community settings, the user will not be retina specialist like myself. The user will be like, the optometrist or optometrist, diabetologist, so it will be a non-specialist. Non-specialist doesn't mean that, diabetes specialist, not specialist, but it's just that the non-specialty specialist that would actually be using such a solution. So then is it going to be cloud-based? I mean, so if you're SaaS, is it going to be cloud-based where if you actually sign up for this, you'll be given a username. So once you actually take a picture, you upload to like the cloud, the platform, it will automatically give you answers. And then you can actually then provide the answers to your patients, right? So that is one model. Second model is something that is embedded inside the system where once you take the picture, once you take the chest X-ray, like say Philips, Siemens, they'll automatically tell you, oh, that is a 96% likelihood, there's a 75% likelihood of having such problems based on the AI solutions. Then, I mean, the questions, so let's take one step back, right? So the medical, so the AI, the governance. So we talk about AI governance, the safety, the AI safety. This is one part. Because before we talk about payment, first we have to actually talk about the level of automation. So that is something that I also actually briefly touch upon. So there's the 3 levels or level of automation that the AI solution is providing. One is fully automated. So then who is, there was a question, who is actually supposed to be answerable to it? If the claims of the AI company says that this solution can act as a fully autonomous, a fully automated system, then the AI company who deploys this will be fully responsible, not the radiologist, right? But if they say, oh no, hang on, this is an assistive tool. So the AI solution will actually provide you with some visualizations of abnormal regions, will suggest something to you, but you will still be the gatekeepers for before you actually convey such messages to your patients. Then the hospital system or the radiologists themselves will be answerable. So it really depends on the claims that the AI company or like the AI the group actually, when they actually submit for US FDA or CE mark, when they actually submit for that kind of regulatory, what are their claims and what is the level of automation, and then that will actually flow down to the level of governance, the AI safety, and then who is the responsible AI part. And then then we talk about business model. So those are the few different big questions that, one question like this, we can actually go for like 3 hours to 4 hours, 1 and 3 sessions to talk about it. But I mean, this is something very important, very good questions. Yeah, thanks. I hope that actually answered your questions, Evelyn.
Yeah, thank you very much. Because I think what you have just clarified is that AI works in different ways, in different scenarios. So you have triage or screening, true triage, which we assistive, and then purely assistive and purely screening. And I actually see applications for this, say, in an NGO, charity, or medical outreach, where you can't have, say, a subspecialty like yours everywhere, and you're holding a diabetic clinic out on the, in the street, or in Vietnam, in Cambodia, wherever. And this can be extremely useful. And then using teleradiology, or in this case, telemedicine or teleophthalmology, it can reach you. So Dr. Park, about these chest x-rays as well, have you had any, you were talking about the fact that depending on how they were trained and how you change your threshold, the outcome was very different. And I also remember what Daniel said was AUC is not enough. I think it was Daniel who said AUC was not enough. Or is it Dr. Park? So, I mean, we had a lot of information today thrown at us, but these are some concepts, I think, which I think our listeners are very happy to know. And especially for those who are, thinking that AI is way beyond them, maybe you have made it easier for them, and maybe they are more interested now to be involved in it. Thank you.
Thank you so much, ma'am. During the entire panel discussion, I would like to hear from Dr. Sherhan Tang, sir, as a part of the Emerging Trends Committee. Sir, what are your views about today's discussion, and what is the future? And please tell us something about the white paper we are working on.
Oh, thank you very much, Raval, and thank you to all the speakers for your wonderful insights and a very interesting exchange of ideas during the panel discussion. And I'm grateful to all the attendees for today's session. I think this is actually really just the start of how the AOSR through the Emerging Trends Committee will engage the rest of our fraternity. And AI, of course, being a very hot topic right now, we are looking for areas within AI that are particularly of interest, and perhaps some controversies where we can further deep dive and try to better understand how we can support the radiology community in our efforts for AI. So thank you very much to everyone.
Thank you. And one last question for Dr. Kwang Ho. Sir, you have seen the development of AI. What is the future? What is beyond AI? Is there a new technology coming up, or what do you see how do you see the future? Professor, sir? I think it's not there. Can we move on?
The question to whom, sir?
Professor Ng Kwang Ho.
Yes, sir is here, but he's muted, sir.
What is your question?
Yeah,
I'm back. Was there a question for me?
Yes, sir. Yes, sir.
Can you repeat that, please?
Sir, you are a legend, and we have seen you. You have seen all the development of AI. So, what is the future? Is there a new technology coming up? What do you foresee, sir?
Oh, I see. Okay, yeah. What you say is true. I grew up we developed some of the earlier computer-aided detection system for pathology, actually, microscopic images, look at cells, volume size, and was involved in the early development before the winter. That was the expert system beginning long ago, about 30 over years when I started, using expert systems and rule-based and so on. Definitely, we see now another peak after 2 winters, and it keep going up. And I'm very positive that it will definitely, this time around, will be fully deployed, integrated. Nonetheless, we still have issues such as we discussed, economic, legal, ethics, and acceptability, and so on to be resolved. I believe to some extent we can, but in terms of technological ones, we are there. But we need to to bring all the stakeholders together, and that is important, right? To buy in for all, and that eventually will be good. They see that it's beneficial from every stakeholder point of view.
Thank you so much. I would like to give the space to Dr. Evelyn Madam for the closing remarks for today's session.
Thanks, Gaurang. I want to thank everyone, especially the Emerging Trends Committee and specifically Gaurang, for bringing together a very stellar faculty whose energy and enthusiasm is hopefully going to be very infectious for all of us. And I learned a lot, and I am still learning. And I thank you all very much for your insights, especially it was very down to earth what you did, and I was very clear actually. And I thought it was very good because you had a general overbroad overview followed by a little bit more focus in medicine. And then even more focus was Dr. Park's experience with his chest X-ray AI CAD. So we can actually see how it distills and gets implemented. So we appreciate the many facets from our speakers. And we actually look forward to actually collaborating beyond just radiology with scientists, with medical physicists, with even, who knows, ophthalmology, if we find some common ground where AI may be helpful to all. But I really hope one day, Vidor, that we will have AI to help us reduce the number of clicks and selections we have to do, because that is actually taking a lot of time. And it does remove some of our energy from the actual work of interpretation. So thank you so much, everyone. And I hope that everybody will stay tuned for further editions of AI webinars from our Emerging Trends Committee. Thank you very much again to everyone for your participation.
Thank you. Thank you.
Bye.
Bye. Thank you.
With your permission, may I end the session, sir?
Thank you.
We get them to take a group photograph.
She has taken. I'll share it with you.
Okay.
Yeah, sure, sir. Thank you, sir. Thank you so much.
Thank you.
I'm ending the session.
So thank you, sorry.
Thank you, ma'am.
Job, Gaurang.